To solve a system of equations using elimination, you're going to do exactly what that says. You're actually going to kind of temporarily eliminate one of your variables so that you can find the other one, and then you'll be able to plug in and find the both variables eventually, okay? And so to use elimination, there are some steps that you can take, and as long as you follow those steps, it'll make it to where the problem's kind of easy to go through, all right? So the first thing that you want to do is you want to look at your equations, and you want to make sure that they're lined up. So what I mean by that is like your x's have to be over your x's, the y's have to be over the y's, the equals over the equals, and then your constants over each other. So if that's happening, then you can move on. If not, you're going to have to make it, so maybe shift some things around so that your variables are lined up. And then you're going to look at one of your variables. And most of the time it'll be x's and y's, but if not, then you just look at whatever variables that you have. But you're going to look at one or the other, and you need to make sure that at least one of them has the same number in front, but it's going to have opposite or different signs, okay? Because the whole elimination thing, the thing that makes them go away, or one of them go away, is this. You have to make sure that they have the same number in front and different signs. And it could either be with your x's and your y's, so we'll look at that in a minute. Once you make sure that's happening, then all you have to do to make the elimination happen is add the equations together, okay? And then once you add them, you'll just solve it and find one of your variables, and then you'll plug in that variable to find the other one, okay? So that's the step. So now let's actually kind of go through the process. So if we were looking at an example, I'm going to start by making sure that it's lined up. If I'm using elimination, it has to be lined up. And so I'm going to look at my x's are over each other, the y terms are over each other, I've got the equals over each other, and I've got the constant over each other. And so that's good, so I don't have to worry about that step. The next one is you're going to look at your x's and your y's, okay? So when I look at my x's, I'm going to look to see, do they have the same number in front with different signs? And so when I look at the x's, I have a 2 in front, and this one's positive, that one's negative. So I have that happening. As long as you have one of these, it could be your x's or your y's, where they have the same number in front and different signs, you will be able to do the elimination very easily, okay? And so that's happening. And notice I don't even care about the y's because I have that happen with the x's, okay? So I know that's happening. So then the next step is to add your equations. So you're going to take your two equations just like you would with like combining like terms, and you're going to add them up. So the reason you want this happening is because what is 2x plus negative 2x? Well, that'd be like 2x minus 2x. So that actually goes away. That's the elimination part. That's the part you want to happen. Okay, so those went away. So that's like technically a 0 right there. And then you add the rest of them. So we got negative 3y plus negative 2y. So negative 3 minus 2 would be negative 5y. And then bring down my equals, and then I add these two. So 6 plus 24, that would be 30. So that's the adding part. Now we just have to solve it. So notice we're going to solve it, and then we'll plug in, just like we did with the other methods, to find the other variable. So to solve this, I'm multiplying by negative 5, so I have to divide by negative 5. Negative 5 over negative 5 is 1. My y comes down, and then 30 over negative 5 is negative 6. So that is, remember, that's only part of my solution. We're looking for, when we're solving a system, we're looking for an x and a y value that works in both. So now that I know what my y value is, I just have to take this, plug it into either equation to find the x. And so I usually just choose the one that looks a little bit easier to me. This one looks a little bit easier, so I'm going to go to the side. I'm going to copy that equation down, and then I'm going to plug in what I have. So I know what the y value is, so I'm going to plug the y value in, which was negative 6 right there. And then I solve that. So I'm solving for x, so the 2x comes down. Negative 3 times negative 6 is a positive 18, and then my 6 comes down. From there, to solve, I have to subtract my 18 to both sides. So then that goes away. My 2x comes down. 6 minus 18 is negative 12. And then I divide by 2, and x is equal to negative 6. So in this problem, when the x is negative 6 and the y is negative 6, it will work in both of those equations. Okay, so you could write your answer like that, or remember, you could write it as a coordinate, because if you think about the graph part of this, if I was able to graph those equations, this would be the coordinate where they cross each other, where they intersect. So make sure you kind of know how these relate. They're all, the whole goal of solving systems, no matter which way you do it, is to find an x and a y that works in both. So you can do it multiple ways, all right? So let's do one more, and then we'll talk about problems where it's not so direct after this, all right? So going through the steps, we're gonna look at our equations, we're gonna make sure they're lined up. So my x's are over my x's, my y's are over my y's, the equals over the equals, and then my constants are lined up. So that part's still done. Then I'm gonna look at either my x's or my y's, and I'm gonna see, does one of those have the same number in front with different signs, okay? So look at my x's. My x's, that has a 9, that has a 4, that's not the same number. And so I'm gonna look at my y's real quick and see if that's happening. So my y's, I have a 3 in front, and they have different signs. So that is happening with at least one of them, and that's all you need. You just need either your x's or your y's that happening with, so we're good there. And then if that's happening, then you can actually go ahead and add the equations, and that'll make one of them go away, okay? So I can go ahead and add them. So when I add them, 9x plus 4x, that ends up being 13x. The negative 3y plus 3y, that actually goes away. That's the eliminated part, and that's the reason why you want that to happen, is so that it goes away. So that's 0. I'm going to bring down my equals, and then 0 plus 26 is 26. Then you just solve. So to solve this, I divide by 13 on both sides. So 13 over 13 is 1. And then x is equal to 26 over 13. It goes 2 times. All right, so that's, remember, that's only part of your answer. So make sure that you don't forget you're looking for an x and a y that goes into these equations that works in both of them. So we got to take this and plug it back into one of them. So choose whichever one looks easier, because it'll get you the same answer. So I'm going to pick this one because it looks easier. So I'm going to take that, write it down. So we got 9x minus 3y equals 0. I'm going to plug in what I found. So my x value is 2. So I'm going to plug that in. Then I solve for y. So 9 times 2 is 18. And then I bring that down. I got to get my constant to the other side. So I have to subtract 18 because it's a positive 18. So 18 minus 18 is 0. My negative 3y comes down. And then 0 minus 18 is negative 18. Then to solve for y, I'm multiplying by negative 3. So I've got to divide by negative 3. Those go away. And y equals negative 18 over negative 3 is positive 6. And so when x is 2 and y is 6, those two will be the only solution that will work in both equations. So you could write it like that, or remember, if you graphed them, that would be the coordinate of where they cross.